computer and you're good to
Is
go.
there an XKCD?
No, there's not an XKCD.
There could have been.
All right, welcome to week 14, mobile application hacking. How to go to the next slide, Thomas?
I know a lot of.
What?
Or not. I'll do it.
Oh, I got it.
Okay, cool.
Okay, I was gonna make challenges and then Meta CTF happened. Sorry, guys. Here's the meeting flag. You can download your gyms, Clash of Clans.
Really?
Oh no. All right. Well, we'll fix that later. Don't worry.
Still plays Clash of Clans.
It does. It does work.
It does.
All right. Good,
I'm
good.
just a fat liar. I tried to know and not lie.
Okay. So first, I'm going to go over like what mobile app hacking is, then some tools you might use for mobile app hacking, and then I'll kind of focus in on specifically Android reversing. And then I'll go into a couple different things you could do with that, and then just ignore the last bullet point. Okay, so mobile app hacking. So given a compiled app, so whether that's an Android app or an iOS app, we're going to try to perform some modification to gain information, whether this be users' personal information, high scores, increasing your in-game currency, locating internal APIs, that's a big one nowadays, or circumventing some sort of security checks, like a PIN to get into an app. Right, so how this actually happens is your source code is compiled by whatever tool you're using into app files. So this really depends on what language you use, but on iOS it's compiled into a .ipa file, and on Android this is an APK, which is literally a zip file remade. So this is a couple tools you can use. So in general, IDA and Ghidra are perfect for this sort of stuff. Just some static analysis of programs. And then the big one for reverse engineering is Frida, which I'll cover later. It's the closest thing we can get to a debugger for mobile apps. Imagine like TamperMonkey or Cheat Engine for phones. And there's a couple small libraries that build on top of Frida. Objection and MobSF that provides some additional functionality that's useful, like certificate pinning bypass stuff. And then some specific like Android reversing tools you might use commonly are JDEX and APK tool. APK tool lets you package a modified Android app back to an app. So you could literally, that's how you get like a patched app. You'd use something like APK tool.
You actually do this, you do basically this exact thing in CS463 as the final one piece.
Okay.
It's really, really cool because they give you an app that you can like decompile and then you disassemble it, then you compile it using a reversing tool. And then you can inject Java and then compile the Java stuff. It's like,
exactly.
really cool. It's some cool stuff.
Yeah. So for small changes, you could use APK tool to get that smally, and then maybe just change a byte or two and recompile it. And then finally, if you have some compiled Java, as most Android apps compile down into .class files, you would use something like bytecode viewer or JDGUI. So why do we start with Android reversing? The main reason is improved tooling. Java is not only on mobile apps, but it's everywhere. So it makes it insanely easy to reverse. And there's a lot of massive tools to take the APK down to Java source code. More resources online. And another thing is, some people might be like, oh, I have an iOS app that I want to reverse. But a lot of apps will share very similar patterns between Android and iOS that's not applied to everything. And you read it. So if they have a similar code base, always choose easier path. So here's like a couple different ways Android apps are made. So if the program's written in like Java or Kotlin, that's gonna be your easiest one to reverse, right? You can just use APK tool and then your standard Java decompiler to recover the best guess at an original Java file and analyze that. React Native is a little bit more complicated. So you're gonna use APK tool to dump the files, and then you're just gonna locate the minified bundled JS file. So if that's your thing, go for it, but that sucks. And then if there's native libraries, that's very similar to if it's just written in Java. So dump files, and then you can use JDEX to figure out which native libraries were loaded and use Ghidra to analyze these libraries. And then Unity, you'll do the same thing. You'll dump files, locate the compiled game, which generally is libil to C object. And then you'll compile that into some DLLs and analyze that in, my favorite is dnSpy for specifically Unity or Ghidra. And then Flutter is just pain. Basically, Flutter is executed with a VM, so it's incredibly difficult to analyze. So really your best guess is you can use a couple tools like Doldrums and Darter to identify the function signatures, but the functions are going to be looking really wacky, so good luck with that. Okay, so I just a small demo for hacking Crossy Road. So yeah, this was supposed to be interactive, but I ran out of time. So basically what you would do is you'd make an emulator and control it with, you'd make an emulator in Android Studio without the Play Store, because Google doesn't let you root a Play Store emulator. And then you'd sideload the Crossy Road APK, make sure everything's working. And then the first thing I did here is I using the command ADB to connect to the phone. So that's what the ADB root and ADB shell does. That gets me into the phone itself. And then I'm going into the /data for Crossy Road. And then you see at the bottom, I do this grep recursive for score. And we see a file pops up, player preference, gives us our offline high score. So all we got to do is change this. So I pop this into Visual Studio Code and then re-upload the changed file, and boom, we now have an epic high score. So then I have a Frida demo. So basically, this is assuming you've already taken the APK, and then this is like maybe the main view of your program. And you see this check here, and it's checking that some property on your system, like your current user location, is Russia, right? So obviously we want to bypass this and get the app to actually run. So the tool for the job here is Frida. So basically what we're going to do is we're going to inject into the application and hook in that specific method and overwrite the functionality so we can do something that we want. So this is how you'd set up. Usually you have a main.py that just connects to Frida, and then you just read a JavaScript file that's your actual payload. So here's the payload you'd use. So basically what we're doing is, the cool thing is we're literally just rewriting Java code and overwriting like the Java string system method. So we overwrite get property to always return Russia, and then we circumvent the check. I don't have a picture, but that's pretty cool. Yeah, Frida is cool. There's one thing you get away from this, it's that Frida is the tool you want to be using for most of these. And then certificate pinning. Some apps will use proprietary or unofficial APIs. And usually what you can do is put a man in the middle attack to figure out what endpoints they use. Here's a couple I recommend up there.
Charles is only $2.99.
Yeah, so Charles is super nice. You can put it on your phone, so you don't even need a computer or anything hooked up. You can just flip a switch. It's a super fast way to do it. Doesn't require really any setup at all. Okay, so I have a personal example. My junior year of high school, the McDonald's near our home does not allow you to order with the McDonald's app until you get to the location. And McDonald's kind of sucks, so it always would take like 25 minutes to get my food, and I didn't want to wait that long. So what I did is I used Charles, the tool I was talking about earlier, to sniff all the API calls they made to the McDonald's app. And eventually I was able to kind of reverse engineer their ordering code call, and I made this small Python wrapper around it. And then I created a script to every day I would create a new account. And then every time you create an account, it gives you this promotion for a $1 Big Mac. And then I would use the $1 Big Mac promotion every day for the next 2 weeks. And then they updated the app. I don't know why they did that. Yeah, really wish they didn't. So now the question is, how do they protect against this? So nowadays, most apps pin their TLS certificates. So I don't really know a ton of the technical details, but basically the server will send over the certificate, and then there's logic inside the app to verify if the certificate is valid. If it's not valid, the connection is terminated, so you won't be able to see anything showing up inside like your man-in-the-middle proxy.
I can explain it.
Yeah.
With certificate pinning, it's basically just hard coded. In super simple, it's hard coded certificates. So the certificates are just like, they are pinned to the application. So it tries to connect to an actual, like that server with that certificate specifically. And the way to get around that is actually to, again, exactly what we're doing here, reverse engineer the app and find the pin certificate and then change it to your minute.
Yeah, I got a whole bit for it.
Oh, do you? Oh,
Yeah.
cool.
So if you've ever tried using Netflix, TikTok, or Snapchat with a VPN, it doesn't work. That's because of certificate pinning.
Is that new?
What do you mean?
With like Netflix with VPN?
Depends on the VPN. Sometimes they'll just say, hey, you can't connect to the VPN. Yeah, that's me at 4 a.m. Okay, so the tool we're going to use to get around this is Frida. So since the check is in app, all we got to do is bypass the check. So there's a couple methods this happens. You can either be pinned in Java, you can use native pinning, so that's like libSSL, or there's Flutter and Dart, which is kind of separate. If you guys are more interested, you can look at this link. So something I did earlier this semester was unpinning the dining hall app. So we can determine pinnings in place. I turn on my VPN, loading bar spins forever. And then I was able to identify that this is actually a Flutter app, which I had never reversed before. So after doing some research, I found a very good write-up about it. And I was able to identify in Ghidra the function that does the certificate pinning. That's just possible func here. And then it might be a little hard to see, but basically what I did is I searched in memory for the bytes of this function. And then what we do here is we replace the value with a 1 instead of 0. Just to always return true for this certificate check. And then on the right here, we have the return value altered each time. And on the left, we can see all the API endpoints. So we can see I have burp sweep running and a request comes through. Yeah, that's it. You guys got any questions? All right, cool. I don't know how to end this.
Thank you, Pete. Great, awesome presentation. That was really cool. Learned some stuff I did not know. I can actually, 1 or 2 things I can actually go take and use right away, which is really cool. I'm going to stop the share. And then, all right, I'm going to end the recording. This has been the last meeting for 2021. So see y'all in 2022. We're doing in-person meeting at Murphy's on Thursday. It's just going to be an end of the year celebration. So also it's Chris's birthday celebration. So birthday for Chris. Anyway, bye. I'm going to stop the recording.